we have a boat that's rowed at a constant speed for 45 miles in 5 hours going downstream, so the current of the speed of the current is added to the rate of speed of the person that's rowing. It's rowed for the same 45 miles, well, upstream in 9 hours. Find the speed of the current. I'm sure there's many ways to do this problem, but here's one way. Let C equal the current speed. That's what we're looking for. And from that, you need to remember that there's a formula that says the distance traveled equals the rate of speed times the amount of time that's traveled. D equals R times T. We'll make a table using this formula, D equals R times T. We'll write it across the top, make the table, and consider two different scenarios. One where we're going downstream, that's where the current speed is added to our rated speed, and the other is going upstream, that's where the current speed is subtracted from our rated speed because we're fighting the current. 45-mile distance going upstream equals the rate, which is our rate plus the current rate of speed, times the 5 hours, and then 45 minutes equals the rate minus the current times 9. Now that implies that if I distribute the 5, I get 5R plus 5C equals 45. Distribute multiplication by 9, I get 9R minus 9C equals 45. Okay, since the rates of rowing R are the same, let's solve for R in each of these equations. So take the first one, the 5R plus 5C equals 45, and isolate the R term and then divide both sides by 5. For the other one, isolate the R term, 9R, and then divide both sides by 9. So now we've solved both equations for R. Now since the R's are equal to each other, let's set one of these equations equal to the other. 9 minus C equals 5 plus C. And now we just solve for C. That's what we're looking for. Move this C over by adding it. We get 9 equals 5 plus 2C. Move the 5 to the left. We get 4 equals 2C. Turn it backwards and divide both sides by 2. We get C equals 2 miles per hour.